Today's lesson is on the remainder and factor theorems. Our goal is to find the factors of polynomials and solve them. The remainder theorem is one way to determine if something is a factor of the polynomial or not. Basically, it says that every polynomial can be written as the product of a binomial, a depressed polynomial, and a remainder. If the remainder is 0, then the binomial is a factor. If the remainder is not 0, then we already know that and we don't have to go any farther. Now, the actual remainder theorem says P of x equals the quantity of x minus r, that's our factor, our binomial factor, times Q of x, which is our depressed polynomial, plus P of r, which is our remainder. Basically what this means is if all we're interested in is determining if something is a factor or not, all we have to do is simply evaluate P of r and see if it's 0 or not. So let's start by doing that. Here's our problem. We have x squared minus 5x minus 4 divided by the quantity of x minus 2. I want to know if x minus 2 is a factor. So the first thing I have to do is figure out what r is. Well, x minus r is the same as x minus 2. So this means r equals 2. So let's do P of 2. P of 2 would equal 2 squared from the x squared minus 5 times 2 from the 5x minus 4. So that's 4 minus 10 minus 4, which is negative 10. Because this is not 0, I know x minus 2 is not a factor. Now, let's say I did want to know what multiplied to it. You know, remember in the old days when you would have to do something like 8 divided by 3 and you got 2 remainder 2? Well, if I wanted to actually know that information, what I would have done is synthetic division. And remember, synthetic division is just using the coefficients and the value of r. R was 2. Our coefficients were 1, negative 5, and negative 4. Remember, our first column was x squared, then it was negative 5x, and then it was a constant. We do our synthetic division, bring the first number down, multiply, put it in the next position up, add down is negative 3, multiply, put it in the next position up is negative 6, add down is negative 10. Remember, the last number is the remainder, exactly the same thing we got when we did just evaluating P of 2, and that the polynomial underneath is going to have degree 1 less than the original. Since I started with x squared, my first term is going to be x. It's depressed because it's lower. So my actual answer is x minus 3, remainder negative 10. Or if I wanted to write it out in factored form, I could write that as x minus 2 times x minus 3. This was 3. This was our divisor. This was our quotient. And then since the remainder was negative, I'm going to use a minus. So it would be minus 10 for our remainder. And if you multiplied that out, you would end up with x squared minus 5x minus 4. Now, even though we haven't exactly defined it, we have been using the whole idea of the factor theorem. Basically, if the remainder is 0, it's a factor. If the remainder is not 0, it's not a factor. So, what I'm going to try to do is actually solve this problem, 2x cubed minus 3x squared plus x. And the first thing I needed to know is, was x minus 1 a factor? Now, I could have just guessed that, but I'm going to go actually figure it out. So the first thing I'm going to do is I'm actually going to substitute 1 into the problem and see if I get 0. So 2 times 1 cubed minus 3 times 1 squared plus 1 gives me 2 minus 3 plus 1, which is 0. So I do know that x minus 1 is going to be a factor. Now, if I know that, now I'm going to go ahead and do that synthetic division and try to find the remaining factors. So flip to your next page. We already know from the previous page that x minus 1 worked. What I have shown here is my synthetic division for x minus 1. So this was 2, remember this was x cubed, x squared, and x. So that means after my division, I'm going to get 2x squared minus 1x. So far, this is what I know. I know that so far I have factors of x minus 1 and 2x squared minus x. Now, that's not quite factored completely, so let's factor that again. And the part we can actually factor again is this 2x squared minus x. It has a common factor of x. So what I'm going to get is x minus 1. And then when I factor out the common factor of x, I'm going to get an x. And then 2x minus 1. These are all of the factors. Now, to actually solve that problem, I'm going to, excuse me, I'm just going to set each of those factors equal to 0. So x minus 1 equals 0 gives me x equals 1. X equals 0 just gives me x equals 0. There was nothing to work on that one. And 2x minus 1 equals 0. In the end is going to give me x equals 1/2. Those three are the roots to my problem. That's where the graph would cross the x-axis. This one had a degree of 3, so we knew there were 3 possible real roots, 3 complex roots, which means they could possibly all be real, and there were 3 real roots. At this point, turn the podcast off and practice the problems 5 through 10 from page 226. They're listed on your sheet. Then turn the podcast back on and check your work and your solutions. Here are the results for 5, 6, 7, and 8. On 5, you can either write it as x plus 1 remainder 6, or if you write it with your remainder as a fraction, it would be the quantity of x plus 1 plus 6 over the quantity of x minus 2. On number 6, remember the depressed polynomial has degree 1 less, so it was x squared minus 4x plus 3. Number 7, it said determine whether it's a factor or not, so I just evaluated p of 3. It was 0, so yes, it was a factor. Number 8, when I evaluated, I actually did synthetic division. I could have just evaluated p of 3, come up with 92, and the answer again is no, that it's not a factor. On number 9, it said determine the binomial factor, so I actually had to make a guess. And the first thing I did was I looked at this 5 at the end and I guessed, okay, maybe 5 goes into it. So I tried x plus 5, did synthetic division, came up with an icky remainder. Could have just substituted 5 in, evaluated p of 5, guessed x minus 5, did the synthetic division, came up with a lovely answer. So I knew it was x minus 5 times the depressed polynomial, which was x squared minus 1. Then I factored x squared minus 1 to an x plus 1 and an x minus 1. On number 10, I made a good guess with 1. So I had x minus 1 was one of my factors and x squared minus 5x plus 6. So then to complete it, I factored the x squared minus 5x plus 6 and got x minus 2 and x minus 3. Now, one other skill that you should have is being able to find a missing coefficient based on some given information, and they said find the value of j so the remainder is 0. Basically what we're going to do on this is evaluate p of r and then set it equal to the remainder, whatever the remainder happens to be that they're asking for. So all I'm going to do first is evaluate p of 2, because in this case x minus r equals x minus 2, so that meant r was equal to 2. So p of 2 is 2 cubed plus 6 times 2 squared minus j times 2 minus 8. And if I complete that evaluation, I get 8 plus 24 minus 2j minus 8. So I get 24 minus 2j. That's p of 2. Now I want to set p of 2 equal to 0 because that's the remainder we were looking for. So completing it, 24 minus 2j equals 0. So 24 equals 2j, and j equaled 12. It's your turn to practice some. Go ahead and turn the podcast off. After you've finished, turn it back on and check your work. Welcome back. The first thing I did on number 11 was figure out what r was, and if x plus 1 equals x minus r, then r is negative 1. I substituted it in to p of x and ended up with 6 plus k. Since I wanted the remainder to be 2, I set 6 plus k equal to 2 and got k equals negative 4. On number 12, the first thing I did was I just reorganized the problem so it went in descending order. Since the highest exponent was 12, the degree was 12. For part B, the complex zeros is always the same as the degree, so it was 12. For part C, when you divide by x, the polynomial is going to go down by 1 degree, so it's 11. The depressed polynomial is always 1 less. And for finding a factor, I just guessed x, and if I guessed x, x minus 0 would be p of 0 to solve, and it worked out, so one factor was x. Now for number 13, it was a little bit more of a challenge. The problem required you to know that the formula for the volume of a cylinder is pi times the radius squared times the height. So the first thing I did was look at the information they gave me, and it said the height was 4 inches greater than the radius. So my height was r plus 4. I substituted that into the problem and ended up with volume of pi times r cubed plus 4r squared after I distributed the r squared through. Now, in the original problem, they also told me the volume was 5 pi inches cubed. So I set 5 pi equal to pi times r cubed plus 4r squared, divided pi out of both sides. Since it was an exponential equation, I did need to get one side equal to 0. So then I had r cubed plus 4r squared minus 5. At that point, it was guess time. So I guessed one of the factors, the radius, could be 1. So I substituted in 1 into the problem and ended up with p of 1 was 0, so I knew r minus 1 was a factor. Did the synthetic division, came up with x squared plus 5x plus 5 was the remaining factor. Set that equal to 0. I knew that x squared plus 5x plus 5 was going to give me imaginary answers. There are not two numbers that multiply to 5 that will also add to 5. So the only answer that was valuable was x equals 1. That meant the radius was 1 inch. This concludes your lesson on remainder and factor theorem.